Good morning, everyone. My name is Bill Schenkelberg, the Managing Director here at Red Sky Alliance. Today I'm going to briefly explain and talk about electricity, a needed component for any computer and associated networks. Today we're going to talk about low voltage power, which is the power that drives all our technology. As I say in every Red Short, you can find similar type information on cyber topics at redskyalliance.org. If you missed any of the previous Red Shorts, you can find them there as well. Electricity was first identified and realized actually many years ago. Our storied US history likes to give credit to Ben Franklin, who was supposedly flying a kite in a thunderstorm and then discovered electricity, which, by the way, is a scientific method that we do not recommend. But way back around 600 BC, an ancient Greek philosopher named Thales of Miletus discovered that rubbing animal fur on amber causes an attractive force between the fur and the amber. By the way, amber is fossilized tree resin. Don't ask me what possessed Thales to rub his pet cat on an old tree, but the Greeks did indeed discover electricity, actually static electricity. So sorry, Ben, Thales beat you by hundreds of years. Okay, now let's fast forward to the 21st century. Almost everything is powered by electricity, sourced from either the electric grid to lithium batteries. Electricity powers just about everything these days, and yes, of course, our computing power, as we've come to really rely upon. Thales and Ben's form of electrical generation is obviously not the proper or really the realistic way to provide electric power. Now we have hydro, nuclear, coal, natural gas, solar, and wind as generations of electric power. One may ask, is all that enough electric power? Some say yes, and many say no. But that discussion is for another day. Today I'm going to be talking about the way we get power from generation to the end user in the form of low voltage power. The US National Electric Code, or as we call it, the NEC, has just approved a new class of low voltage wiring, which will help in the overall transmission of electricity to our current and future technology. Until recently, there were three classes of low voltage or power limited circuits. Last year, however, a fourth circuit type was introduced into the NEC. Going way back, electrical codes were originally set up regarding fire safety and, more important, human safety. Now codes cover all levels of electric technology that are in our homes, businesses, and public areas. Limited power circuits or low voltage, like the new Class 4 circuits, will be highlighted here today. To make a clear distinction between wiring for ordinary, quote unquote, ordinary circuits and specialized circuits with limited power and or voltage, the NEC classifies circuits based on their electrical usage and how they should be applied. Technology uses these type circuits. Ordinary is considered the 110 wiring we see in all of our homes and businesses. Limited power is what powers most technology tools and appliances. So you may be asking, why does any of this matter? Because we need to get smarter. First, computing and associated networks need limited electric circuits. Second, and even really more important, these circuits need to be safe, the ones that power our computer users. So what are these classes? Think of Class 1 circuits as relatively safe if a person is shocked, but they may possess a fire hazard. Believe it or not, that's in the Class 1 definition. But if you've ever been shocked by a Class 1 circuit, you know it, and it hurts. And that shock could cause a spark, which may ignite a fire. So to give an example of that, you typically see the Class 1 circuits in environments where motors and compressors are in use. So next, a Class 2 circuit is considered safer regarding fire initiation and provides acceptable protections from electrical shock because it's in lower voltage. Class 2 power loads are often delivered through Power over Ethernet, or the PoE cables, which combine power and data in a single cable run. This combination was created to save on valuable installation time and money. So if you look at the pictures on the screen there, the applications could include, audio systems, low voltage wiring, lighting type systems that you may see outside, security systems, and thermostats. So if you ever had a chance to change your thermostat in your house, you may have received a shock, but it was not a shock that would make your hair stand straight up. It was a low voltage type shock. So class 3 circuits then function very similar to class 2 circuits, but with higher voltage and power limitations. Class 3 circuits are occasionally used to power equipment that requires more power than what class 2 can quote unquote safely provide. Similar to class 2, class 3 power loads are often delivered through data cables. Class 3 circuitry can include certain types of nurse call stations, commercial public address systems, and commercial intercom type systems. So why do we need a new wiring system? A few years ago, the NEC created the Pulse Energy Transfer Group, which was an electrical engineering task force within the NEC and was formed and brought together to provide recommendations to code-making panels to create this Class 4. Class 4 circuits bring new type of circuitry to the NEC. This class will be incorporated into the 2023 NEC as a part of the new Article 726, which was proposed under this new publication. Class 4 circuits provide the convenience and power of low voltage power, just like the PoE, or the Power over Ethernet, that we see in the Class 2 and Class 3. However, the Class 4 also offers close to 20 times the power of a PoE across hundreds of meters, and it presents a safe alternative to AC power. Like Class 2 and Class 3, Class 4 power loads are often delivered to technology that combines more power and data in a single cable run. This cuts down on installation time and money, providing longer, reliable, and more powerful electric runs. This helps constantly emerging technology. Again, think of being smarter. So this is important because we have higher voltage now, which could cause more fire and more human risk, right? If we have more voltage, it's a higher risk there. So if someone accidentally touches exposed wires or splash water onto a Class 4 circuit during its operation, then the circuit immediately and automatically shuts off before causing a fire or human harm. To limit this hazard, a transmitter and a receiver monitors for faults and controls the power delivery. Remember, I just said Class 4 can deliver up to 20 times the power of other classes. Bigger shock, yet is now more safely protected. This safety method is obviously safer than an electrical type mechanical breaker. If you've ever seen the breakers in your house, this is run by computers and would immediately shut off that power. Whereas when you have a mechanical type breaker, there's always a chance for failure. This technology makes Class 4 circuitry just as safe, if not safer, than Class 2 and Class 3 circuits, while offering more available power. Again, in an infrastructure supporting new technology, it makes the circuit, again, safer. Okay, I used the word safer now a few times already. Whether you agree or disagree, the world is heading to becoming a global, interconnected with all its various smart cities. These smart cities, associated businesses, and residential facilities need an abundance of low voltage power. Class 4 wiring will help in new and remodeled construction, or should I say smart construction. As smart buildings become increasingly intelligent, experts predict that Class 4 usage will explode. Class 4 power is already being used in all types of markets, which include airports, Class A type offices, hospitality environments, stadiums and arenas, warehouses and manufacturing plants. And within these environments, Class 4 circuitry supports technology like distributed antenna systems, passive optical networks, PoE type LED lighting and other systems used in PoE type switches, power distribution infrastructure, small cell and 5G radios. A shining example of a smart building is the Circa Resort and Casino in Las Vegas, Nevada. This casino is a great example of what the future holds for Class 4 circuitry. Instead of using dedicated AC power, the resort's owners chose digital electricity, or DE, to serve as its backbone power distribution infrastructure. DE decreases energy use and creates an intelligent building that can take advantage of cutting-edge technology like advanced building automation, digital in-room controls, cryptocurrency exchange kiosks, which obviously a casino really likes, and LED-type lighting. Their Class 4 power circuitry is used to power everything from lights and switches to in-room climate control and wireless access points. Smart technology is here, and it's here to stay. So why did I talk about Class 4 circuits? Well, aside from possibly boring all of you to tears, I wanted to impress upon you just one small aspect of current and future technology, but a very important aspect of the future. Technology, which is changing by the day, needs electricity to power technology's tools. Low voltage power is a current technology standard and will power smart cities of the future, not to mention all 16 sectors of our global critical infrastructure and key resources. If you have any further questions, please don't contact me. Call a certified electrician. But if you have any questions or comments on the cyber implications of low voltage circuits, you can contact either Jim or myself via the emails you see on the screen. I hope today's talk was informative, and I hope to see you next week on the 24th for another Red Short presentation. Take care and have a good day.